what you need to do with labeling and all those kind of things. So we're very early stages, and that's OK. But we have a long way to go. So why apply AI to healthcare? The first one is healthcare is #1 industry in the United States. $3.7 trillion industry. It's growing 5% per year. So it's growing actually much faster than the United States is. It's projected to reach 5.3 trillion by 2025, which might bankrupt this country. But so it's the largest industry by revenue, by headcount, by growth rate, by everything. Right now, it's #2 in research and development budget. In 2 years, healthcare will be #1 in research and development budget.
What do you mean by healthcare? What's included in your bucket?
So healthcare, I try to include everything related. So it's usually healthcare and life sciences. Life sciences.
How is regulatory, because it's heavily regulated, so how is regulatory from the government side adopting these changes in AI, because it's always an impediment, because AI runs on data and it's always hard to get data from healthcare providers or startups who are working on this?
Yeah, it's actually, OK, the question was, how do you deal with highly regulated industry? Healthcare is highly regulated. It's actually a little bit worse, because first, it's highly regulated. Second, it does not protect IP in the way we are used in technology industry. So the information broadly shared. So if you are sharing your best findings, how do you make money? In terms of regulation, it's, if you facing with a certain set of laws, you have to abide the law, or you go to prison. The level of regulation is somewhat high, but I think I'll get a chance to get to it in the later slides. There are very specific regulations around data and how data can be shared and not shared, which is usually a big impediment to implementing AI in healthcare. So #2 in research and development budget is going to be #1 in 2 years. So if you want to find a good job, which is growing, healthcare is the place. It actually has #1 in terms of AI opportunities. It's also #1 in terms of AI startups, and most people don't realize it. But the largest number of VC-funded AI startups are in healthcare. And I have a slide on that later in the deck as well. And finally, well, healthcare is a way to save lives. So what are the major applications of AI in healthcare? There are a lot of different areas, and healthcare is a big space, so I try to structure it in something a little bit more compact and logical, so it's kind of easier to follow. There are 3 basic areas. One is diagnostics, or medical intelligence. The second one is personalization, or treatment plans. And finally, optimizing the United States healthcare system. All 3 are very important. The first one is diagnostics. So there are 3 different areas within diagnostic space. Early diagnosis, health monitoring devices, medical devices industry. To answer your questions, what's included here. And finally, medical imaging. Medical imaging is also an industry in its own right. So let's look first at early diagnosis. The poster child for AI is sepsis. So you guys know what sepsis is? Not many people, but some people know. So let's say infection enters your body because you ride a bike and hit a wall, or something happens, or you went through the surgery. So infection enters your body, takes hold. Your body releases a bunch of chemicals to kill the infections. And sometimes the amount of chemicals released is so high that it kills you. So your organs start failing. This disease has very rapid onset. Many people die within a few days. Your probability of survival decreases about 7% per hour once you hit the stage of severe shock. Sepsis is #1 disease for hospital cost, in terms of hospital costs. Many people don't realize, but like cancer or the heart attacks, actually you spend a small amount of time in a hospital and then you're released and you're outpatient. Sepsis, you stay in the hospital for the duration of the treatment when they administer all these antibiotics and other treatments. So sepsis is very hard to diagnose because the indication of sepsis are what's called non-specific. So your heart rate goes up a little bit, just a little bit. Or your breathing goes up a little bit. So how do you know if it's sepsis? Or let's say if you go on stage, most people have a heart rate goes up, right? Maybe I have sepsis right now, right? Or you go down the hall, your heart rate goes up, right? So how do you know what's sepsis and what is just a normal, normal condition? Hospital try to apply traditional techniques, traditional programming tools. Every hospital, every CEO has a dashboard which things are like flashing, which hospital has what sepsis patient, alerts, whatever. It doesn't work. First of all, when you write things precisely in a traditional programming way, you have to specify your rules in a traditional way, right? It's like if your heart rate goes so high, then raise an alert. Well, sometimes you miss the onset of sepsis altogether, and sometimes you raise the alert too soon, and healthcare professionals don't trust the system anymore, and your whole effort is wasted. So this is a great place where AI can make a tremendous progress, because well-developed and well-trained AI model are much more nuanced and can capture sepsis and separate sepsis from a more traditional, going down the hole and stuff like that. And so the sepsis is one of the most promising areas where AI can be implemented. So in this particular paper, they show that they can detect the sepsis about 8 hours earlier. So for adults, it's about 8 hours earlier. For children, it's about 6 hours earlier. 6 hours is a big deal because your probability of survival goes by 7% per hour. So if you're interested in this paper, you can look it up. So this is just a very basic example how early diagnostic is happening, right? This is same type of technology can be applied to many different areas. In case of kidney failure, you can predict it 60, 90 days ahead of the actual failure, pretty reliable. In case of diabetes, do you know how much earlier you can predict it? About 5 years. You can obviously detect pre-diabetes condition, but you can detect it 5 years earlier than using traditional methods. So this is a very typical application of AI, early diagnosis. The challenge, of course, in most cases in healthcare system is the challenge is not actually writing the algorithms, even though there is a challenge with that. The challenge is to implementing the algorithms within the real healthcare system, because it's a very human process. So unless somebody does something differently based on the algorithms you wrote, the algorithm is useless. Right? So the challenge in many cases in healthcare system is not the writing algorithms, but finding a way into the actual application. So the second area is medical devices. So on the left, you have a traditional hospital devices, big giant machines which capture your heart rate every few seconds or whatever, right? They have all the information. They cost a few $100,000. You can apply AI there. On the right, you have the consumer devices like Apple Watch. Apple Watch can now capture some of the conditions like atrial fibrillation. It's one of the first algorithms, AI algorithms many people develop because it's pretty straightforward to develop. And consumer devices will continue to add more and more functionality like that. Now, the doctors think about it as a toy, but in some cases, actually can save your life as well. The middle category, I think, is the most interesting. The middle category is actually emerging right now. And it's a special purpose devices. This picture particularly is for the Medtronic, which is a large device company. It's a mobile app for people to manage diabetes. But you have a whole bunch of different mini devices. Many of them are actually made in China for some reason. So there is a big trend in China making those devices, which is special purpose device. It's usually like small size something that not a watch but some kind of small size device, which can track, monitor a very specific condition you have, and for people with that specific condition, it can significantly improve the quality of life and the duration of life. Those devices proliferate like crazy, and they become more and more niche. Those devices only capture few time series, right? From AI point of view, they're not very rich source of data, but they capture the right time series. So that's kind of very interesting. Finally, the medical imaging. Medical imaging is the area which attracted the most attention. So this particular example is from a recent UCSF study where they were trying to predict Alzheimer's. And they figured out they can do it about 6 years earlier than it was done before. You can look up a paper. It's available online. There was another similar study done on breast cancer a few months ago. I don't know if you guys saw it in TechCrunch. So they can predict breast cancer about 5 years earlier. Of course, 5 years earlier, not you're predicting, right? So the cancer is not developed yet. So what they're saying is they're looking for particular density of tissue, and saying that particular density of tissue will be associated, is likely to be associated with breast cancer 5 years from now. So a very, very interesting approach. The challenge with that is, okay, what do we do about it, right? We have a way to treat cancer when we know there is a cancer, right? There is chemotherapy, there is radiation. But what if we have a high density of tissue which might or might not become a cancer, right? So this is one of those things where AI is one part, but restructuring society or restructuring our healthcare system about those predictions is where the value is going to come. Because if we can predict things accurately, and if the healthcare system is able to deal with that high-density tissue rather than the cancer itself, the cancer might never actually happen, but we have to restructure the system and find new treatments for the things which we don't know existed in the past. However, within a medical imaging space, actually, there are a lot of challenges. In many cases, people think, well, I'll just develop one algorithm and it will work very well, and I make millions of dollars. Unfortunately, it doesn't work this way. There are some limitations AI have. So some of the limitation is AI can detect only the things it was trained to detect, and it does not see the big picture. Another one, the patients don't trust AI as much as they trust doctor. And then AI is very sensitive to resolution of devices. Anyway, so there is a set of limitations which makes it more difficult to say AI will replace doctors. So in fact, AI is not going to replace anybody anytime soon. But what we need to do is to have AI as an assistant to a doctor. So what we need to think about is not AI diagnosing something, even though we have an article about it. It's a little bit abstract. What we need is the AI being in a support position to a doctor, being able to help the doctor to diagnose diseases, treat diseases. So the most interesting applications of AI is actually not diagnosis, but let's say screening. Or you might say, okay, I want you, algorithm, to go through the database and find similar cases to what I'm looking at, which were previously misdiagnosed, so that the doctor becomes more educated about the particular condition. So don't try to say the AI is going to replace doctors. What we need is to enable doctors to do a better job. Another challenge with the medical imaging is just the sheer number of different conditions that can be diagnosed. This is a high priority for our company, for our medical imaging division. There are 20-30 conditions there. Alzheimer's is not even there, right? There are some high volume, high frequency conditions that need to be done first. So dozens of different conditions. Every device is different. Pictures look a little bit different. Resolution, calibration, all those kind of things. Basically, you're looking for like thousands of different algorithms that needs to be developed in order to make the whole thing effective. It's coming, but it will just take a little bit of time. The second area where AI is applicable in healthcare is personalization or treatment. The first one is precision medicine. Many of you already heard about genomics, proteomics, all those kind of things. This is a project by National Institute of Health called All of Us. Do you know what the number one step? What are they working on right now? Getting the data. You think startups are alone? This is government, right? So in 2015, Obama administration launched a big project, All of Us. We're going to collect data, complete data set for 10 million people. So complete data set means your medical records, complete medical records, right? Because right now, if you have a primary care physician, he has history on you. Hospital has a different database. Your dentist has a third one. Genetic data is all together somewhere else. So even if you are a customer of healthcare system, your data is probably spread over 10 or 20 different systems which don't talk to each other. So this is a project which was launched by the government to collect complete data set on 10 million Americans. The only way to actually get this data is for a person, you, go to all of your healthcare providers, get the data, and then give it to the government. There is no way around it. So they announced that so far, so it's been 4 years, they got data for 100,000 people. So I'm making progress, but very long way to go. So this is government, and the big first step is just getting the data. And we still have a lot of work to do. Personalized treatment plans. This particular paper is from somebody at MIT. They did a project and say, can we improve the chemotherapy radiation treatment for cancer patients? And with an AI, they tried to do several experiments. First, they said, OK, what if my objective is to minimize the size of the tumor as much as possible? Well, if this is your objective, so what you do is they give the maximum dosage possible that the body can handle. So if you have just one objective, minimize the size of the tumor, your AI will recommend the same thing as your doctor will. However, if you give AI multiple objectives, let's say if I want to minimize the size of the tumor, yet to help person live a normal life so people life don't become completely miserable, right? So what they find is, if you have multiple objectives, maybe you will skip some dosages. Maybe you reduce some dosage by 25 or 50 or 75%. Because if you have multiple objectives, you will have a different treatment plans. But now, you can only build those treatment plans using AI. You cannot build that by guess, right? You need to have all complete information. You need to watch a person's reaction to particular chemicals and make adjustments on the fly. So very promising for people who get a lot of pain from the treatment. Another final area in this category is clinical trials. So in the United States, drugs are pretty expensive. The biggest problem with it is actually system failure. So only 3.4% of oncology clinical trials are completed. So those are people who are more, the most sick. Other clinical trials are not that bad, but oncology are the worst. Most clinical trials don't get completed because people don't stick with them. So people drop off. You don't have enough people. The trial is canceled. You have to restart from all over again. Only 3.4% are completed because most of them cannot hold the people, or cannot find the people, or cannot keep the people within the program. At the same time, only 5% of the patients enrolled in anything at all. So what you have a big mismatch. Why do we have big mismatch between patient and the need of the drug discovery? Because it's a very manual process. So if you are the drug company, what you need to do, you need to contact 200 physicians, within your specific area of interest, hoping that each of them will find 1.5 patient because of those the inclusion, exclusion, and all the conditions that you put on them. So most of the physicians don't have that many patients, so they end up giving only 1.5. And then if 20% of them drop off, then you have to start again. So we have a very kind of narrow, like a bottleneck, that the company who runs the clinical trials need to personally know the doctor who needs to personally know the patient. And that becomes a very inefficient system. The efficient solution, of course, we have all the data in AHR, run algorithm, figure out who fits the trial, and bypass the whole bottleneck. Now, it's actually kind of sounds like an ideal AI problem. It's actually not that easy to do, because the drug companies don't have access to the electronic health records. And anyway, so the ownership of data becomes a big issue. And finally, optimizing healthcare system. There are 3 areas of smart electronic health records: payment accuracy, and patient notification and retention. So according to government statistics, about 1/3 of healthcare spending is wasted. So 1/3 of 3.7 billion is of 3.7 trillion is $1.2 trillion is wasted. This number is per person for US. So unnecessary services, $800 per person per year in the United States. And if you don't go to doctor, you're still paying this $800, right? This is per person for everybody, every man, woman, child in the United States. The second one that I like, billing errors. So we have about $200 billion in billing errors in the United States healthcare system. Now, this is a government statistic. This is not something that we came up with. So there is some fraud and some inflated pricing, but a lot of it is just benign and mismanagement and inaccuracy within the system itself. So a lot of it can be actually fixed. And actually within AI system, this is actually in many cases the low-hanging fruit. As you think about how AI is going to progress, it's not going to happen everywhere at the same time. So what you're looking for is low-hanging fruit first, then something in medium term, and then long shot will take a bit longer. So one of the basic needs for the smart electronic health records is understand medical text. So right now within the United States healthcare system, we have massive amount of information on everybody, on everyone who is in the system, right? So average person who uses the healthcare system on a regular basis, we have several hundred pages of information, about 400 pages per person with a medical history. So every time you stay in a hospital, every time you go to a doctor visit, there are notes generated. 80% of the data is in text, and 20% in some kind of coding, in some kind of codes. So 80% of the data was in a text. So unless somebody reads this text, this information is not known to anybody. Now, knowing the complete medical history can actually be extremely helpful. There was a paper which just looked for the sign of depression in electronic health records and used this information to help to treat HIV patients. So what they found is simply by knowing that the patient also has a depression, you will change course of treatments and you will get better results just by having more complete understanding of the patient history. So understanding medical text is extremely important. But the challenge, of course, with this is we cannot read this, right? Like if you try to read it, Mrs. Roloff was admitted and underwent thoracentesis. The pleural fluid revealed metastasis. So I cannot understand what's written, right? But I have to train the computer to understand what's written in this text and to make medical suggestions. So that's the challenge with medical text. A lot of medical text needs to be converted in what's called ICD codes, which is diagnostic codes, or the treatment codes. We have diagnostic codes for everything. ICD-10 is the latest system. And in addition to the basic stuff like flu and cold, we have ICD-10 codes for all kinds of interesting things like bitten by a cow or stuck by a worker. So we have the coding system. So now what we need to do in many cases, some of the first steps is just to convert the medical text into the codes, which can be used for either managing healthcare system or for improving the patient treatment. Another problem that we worked at our company is medical claims, since we're the largest clearinghouse for medical claims. With the United States healthcare system, there is about $3 trillion of medical claims generated every year. About 9% of them get denied. So you send a medical claim, you wait a month, and they tell you you forgot an attachment. And you said, oh, I didn't forget it. You didn't find it, whatever. So $262 billion get stuck just in that little process. Very much a predictable problem. This is something that we already have a project, and it's working well. So very solvable problem. So small, you would think, medical claim billion is insignificant, but if you think about the losses within the healthcare system, there's $100 billion in losses just in that particular area. Another interesting area that we worked last year is dual enrollment. So in the United States, almost 60 million people are Medicare beneficiaries. About 1/3 of them live below poverty level, which means 20 million people live below poverty level. Medicare does not pay for everything, pays for majority of expenses, but not everything. So people who live below poverty level are eligible for both Medicare and Medicaid. Now, if they don't enroll in the right program, what it means for those patients who live below poverty level is that they either have to not to get the medical treatment they need, or they get it and declare bankruptcy, basically. So just getting the right people to the right programs that the government already provides, you can help a lot of the people who need the help the most. So we talked about AI in healthcare. So there are 3 different areas: diagnostics, which is early diagnosis based on electronic health records, medical devices, trying to extract the patterns from the time series, and medical imaging, which is all CNN, of course, neural networks. Then personalization, precision medicine. Precision medicine is the ability to map genetic or proteomic or other information to actual conditions. Right now, we can do it in about 4% of the cases. 96% of the cases, we have no idea how to map. A lot of work to do there. Personalized treatment plans. For many patients who are in a serious condition or undergo very harmful treatments, there is a huge amount of work which can be done to make their life a lot easier. Clinical trials is a big area where the system basically failed to work efficiently today. And finally, optimizing the United States healthcare system. Up to 1/3 of the cost can be eliminated if we do things right. Now, if we look at what the startups are doing, the startups are everywhere. So this is a report from CB Insights. So if you think about whatever you can think about, it's probably on this chart, and this is only 100. So CB Insight has a database about 1,000 startups that are doing stuff in AI. And it's clinical trials, risk analysis, nutrition, devices, genetics, imaging, like everything we talked about is there in one way or another. But there are obviously challenges. Within healthcare, there are 3 kind of big challenges. First, many people in Silicon Valley that come in, Google or Facebook, get do a lot of AI for things like web ads, right? Web ad is the same. It's shown to the same way to every person, every way. There are billions of them, and it's all pretty straightforward. Within healthcare, you don't have that much of the one huge market, but you have a huge number of smaller markets. So if you develop an algorithm for Alzheimer, stage 2, you might need different algorithm for Alzheimer's stage 3. From different cancer is, like there's thousands of different cancers. You need different stages. You need to train algorithms for each of them. So what you need to do is not to achieve highest accuracy for one algorithm. What you need to find a way is to build the algorithms like in a kitchen or conveyor belt. So you enter the area, and you try to build a whole set of solutions for that particular space. So you don't reinvent the wheel every time. So we have a lot of variety of applications rather than one thing that solves everything. The second one is data. Data is obviously regulated. If you do things wrong, you go to prison. There is personal health information, and it's protected by law. There is HIPAA. There is additional laws. Within Europe, you have GDPR. So you have to follow the law. If you think that somebody will just give you data for free and it's going to be perfect and clean, it's probably not going to happen. So it's probably going to be you have to find a partner you can work with, and you have to provide a real value to that partner in order to have access to the data without having any ownership of the data or something like that, right? There are some cases where the data is being made public, mostly for research purposes, but it's a tiny, tiny set of what's available out there. So you have to respect the data because there is no way around it. Also sometimes people try to work with US healthcare data from Europe or vice versa. That's the worst thing you can do because you get both HIPAA and GDPR, and it's a nightmare. Try to avoid it as much as you can. And finally, you have to understand the workflow. So the fact that you implemented the AI algorithm doesn't make any difference unless it's implemented somewhere. So if your algorithm creates something or predicts something, you need to know exactly who is going to do what in response to that thing. Because many IT projects, many technology projects within healthcare systems often fail because it doesn't change the behavior, it doesn't change the process. So you have to figure out how to make your work a reality within a system. I already talked about that we're early in technology adoption. This particular slide is not specific for healthcare system, but it's just one of the slides from one of the recent OpenAI papers. So what's technically feasible and what's economically viable are two different things. If you have unlimited budget and unlimited compute and unlimited data and unlimited manual effort to fix the labels, you can do miracles. In real time, you have a budget constraint, time constraint, compute constraint. So what you need to do is you need to look for that little triangle in the middle, right? So what you need to find is a project which can be technically feasible and economically viable at the same time. Obviously, as we go, as the tools become better, as knowledge becomes more widespread, this area is going to become bigger. But for now, it's very important to choose your projects very carefully. And finally, one of the last slides I have is, within healthcare, trust is very important. We have to do a lot of work to get the patients to trust AI. And it shouldn't be like trust AI in general, because AI is whatever, right? It's not a thing. So what you need to show them is efficacy of your work you're doing, and you need to show that you have your best intention and you're doing a good job in order to make it work. So both the trust in the company and the trust in technology at the same time is the challenge for AI in healthcare. So that's my presentation. Thank you very much. We have time for questions.
healthcare to get all the data in one shot, in one place?
Yes, the question is, do the countries with nationalized healthcare system have all the data in one place? And UK is one of those countries. Indeed, what was it called? National. Anyway, so there is the government entity which manage all of the hospitals in the United States. Oh, sorry, in the United Kingdom. They do run their own AI trials. So because they have the data, they can mandate which AI trial is going to be run and which AI algorithm is going to be developed. It's promising. Not everything is comparable to the way United States healthcare system works. So some of the knowledge developed there can be transferred to the United States. Some other stuff is not transferable, unfortunately.
So do you see that because of all the fragmentation and the policies and data privacy and all of that, I mean, it is harder for a startup to sustain for a longer time? I mean, the startup can innovate, and the longer term, since the bigger companies have already figured out this government regulation, when they will acquire, I mean, that's how you see the future? Because it seems to me that for a startup to sustain, because who is going to pay for it, and they don't have the expertise about, the government and all of that, right? That's how I see this.
So the question is, because of the government regulation and fragmentation, would it be more difficult for a startup to build a company in healthcare space than it is for established companies? So my answer will be like kind of twofold. On one hand, yes, indeed, AI is right now in the early stages of AI adoption. Larger companies already have have an advantage. We're in Walmart right now, so the companies have large companies have an advantage. So this is true that large companies have an advantage during the early stages of technology adoption. However, that's always the case with any technology. So AI is not particularly unique in that respect. Large companies have an advantage during the early stages of technology adoption. But in many cases, this advantage is actually not realized. So large companies try and sometimes succeed, sometimes don't. And they do end up buying a lot of startups. And the second part, if you look at the valuations, VC valuations, how much money VCs put into AI startups, they actually put more money than in normal startups in healthcare. So AI healthcare startups get more money than AI startups in general. Because the opportunity is bigger, the inefficiency is bigger, so VCs are putting more money in. However, the success rate tends to be lower than average. So it's easier to raise the money, but it's harder to actually succeed. So that's kind of easy where we are right now.
Is there much certification or regulation involved? Like if you have a medical device, FDA will certify that. Is there anything like that with the data? And let's say you have to refine an algorithm, you have to recertify. Is there something like that involved?
Yeah, so FDA is actually started a program specific for AI algorithms. They actually now certify algorithms. And they actually have a pre-certification program. So if the company proven to be doing a good job, they will pre-approve your algorithm ahead of time, which is kind of funky. So FDA is kind of a barrier, but they're also innovating. So I don't know if they're actually the biggest barrier. I think the much bigger barrier is data or the adoption. The adoption is the biggest barrier. Yes, please.
This goes back to an earlier point you were making, but do you see any parallels between the adoption and impact of spreadsheets being similar to what we should expect with, say, AI and machine learning?
Yeah, so the question was, is there some parallels with the adoption of spreadsheets? And yes, I agree, absolutely. So right now we're about AIs where the databases were in the 70s. Do you guys know where the databases were in the 70s? It was flat file. And AIs we operate with flat files. So that's kind of very similar. So yes, so we're in early stages. Right now it's more researchy, then it's going to be engineering, and then it's going to be mass production and sales and whatever. But yeah, the development and adoption technology should be very similar to the traditional computing we already saw. Yes.
What is the
So what is the problem with anonymizing data? So yes, you can anonymize data, remove names, addresses, etc. It has to be certified by statistician. So for example, if you have one cancer patient in a particular zip code, and you removed all his names, but he's the only one, then he's still considered identifiable. So yes, you can de-identify a certain amount of data. It costs money, a lot of money. Not all the data is de-identifiable. And then the identities actually has a lot of value, because identity is how you match the data from different data sets. If you don't know who that person is, then you only get subset. So yes, some data de-identified is available. It's available publicly. You can buy it through brokers, whatever. But it's not the ideal solution in any case. On the back.
Do you have advice to a startup that's going to do a product on, like, let's say, diagnosis, applying AI to diagnosis? How do you structure the deal with, say, a company where you train on their data so you can do this? What's the method to approach this?
So the question is, if you want to do diagnostics, how do you work with the company who has the data in order to do it? Well, I mean, that's not an easy thing. You probably need to have a relationship. You need to find a spot where they have a need, which is not addressed. And the need has to be very severe and dire, so they're willing to do something about it. Don't assume that they're going to give you the data. They're going to sign you a bunch of things in blood. But if you own your own model, that's fine, right? So there is no easy condition, but there are ways to do it. I think in many cases, so what happened in the last few years, a lot of healthcare companies, all the hospitals, big hospital systems, they all did AI projects. But most of them are POCs. And sometimes they're pretty nice POCs, like 250K or whatever. So they do POC on something very basic, very standard type of situation. They learn from it, and nothing happens after that, right? So when they do POCs, they often find that, okay, my data is missing, my data is not labeled correctly, computing power is wrong, or maybe consultant is wrong, or my subcontractor is wrong. So sometimes you just have to be flexible and kind of continue to working with different companies, because if you find somebody, it doesn't mean that you will be able to stay with that person until the project is successful.
How do you scale that?
I don't know. Good question. Yeah, I think it's a one-off, and it's building relationships and working for solving people's needs. That's very dire for them. Yes, please.
So for us to get more dependent on predictive diagnosis, what is the target probability? For example, I'm concerned about false negative in terms of getting diagnosis. Using all kinds of different algorithms, what is kind of targeted false negative rate that is acceptable for applying AI into healthcare?
Yeah, so the question is, what's the acceptable accuracy rates for the AI in healthcare? So all of the papers that I was mentioning today, they all have like 92, 95 type, 98 type range. So if you don't have 90s, you don't publish a paper at all. Now, in real life, it's not enough. It's usually have to be higher than human accuracy. The human accuracy actually varies dramatically. There are some areas of medical imaging where the human experts are doing an awesome job, and actually beating them is quite hard. And there are some areas where it doesn't work very well, so it's actually easy. So I think the next barrier is to be better than human. But even if you're better than human, sometimes it's not good enough. Because if you say, oh, I'm as good as a doctor, then why should I use your AI algorithms? So you have to do either significantly better by a significant margin, or do it earlier. So a lot of papers I was showing is, if you can predict sepsis 6 hours earlier with 7% probability of death per hour, that's 40% survival rate. That's a big deal. If you can detect breast cancer 5 years earlier, that's a big deal. Alzheimer's 6 years earlier, that's a big deal. So sometimes you don't go accuracy versus accuracy. Sometimes you look for additional benefits of your technology.
Do you guys have any program for engineers to understand the medical terms and also the vice versa, like whatever the stuff you guys want to build, like train doctors or nurses, like to understand what you guys have built. So there's a vice versa program because engineers have to understand the medical terms.
Yes, so do we have a program for understanding medical terms? We don't. And it's actually a big problem because every time new people come to healthcare system, most things don't make sense. So I think the only way to do is get into it and start working with it. Even for engineers we already have, it takes a very long time to figure out what's going on because you know your piece of code, but you have no idea who's using it for what reason. So that's definitely a big problem. But there are different ways to get into the healthcare system. So did I answer your question? Thank you. Yes, please.
In that triangle of overlapping economic and technical feasibility, in your view, what are some untapped problems that still exist?
So if you look what people are doing today, let's say if you look for the drug companies, right? It's like, okay, what do the drug companies do with AI? In theory, you would say, oh, they're going to discover new drugs using AI. Well, maybe sometimes. It's like, okay, if they're not doing drug discovery, maybe at least they're doing clinical trials. Well, not quite. They're doing a lot of commercialization. So a lot of AI is applied today to commercial applications to improve sales and marketing. So a lot of the early, low-hanging fruits are optimizing the system, the way the system works. The same cases in healthcare. PwC, PricewaterhouseCoopers, they did their report on AI. They forecast it's create $15 trillion of value within the next 10 years or something like that. The interesting part of that report is actually not the numbers because numbers are kind of the same everywhere. The interesting part is they separated the opportunity into ready to go, medium term, and long term. And if you want, you just look it up, this report, PwC, AI forecast, something like that. And for the healthcare, they say for ready to go is insurance and scheduling, something like that. And medium term is human-assisted diagnostics or something like that. And robot doctors is a long term. So sometimes you can work on the short-term problems if you are kind of commercially oriented person, or you can work on the medium-term projects. Probably long-term is probably not the right place to work on because you will never see your results. Yes, please.
How do you deal with possible bias in the algorithms when they apply to healthcare, especially when you have the most interesting aspects of a 1 to 2% sample, occur only 1 to 2% sample, say like cancer detection, and when you have really big differences in sample sizes of classes, you just end up with bias?
Yeah. How do we deal with bias in algorithms? Well, actually, the bias already exists within the healthcare system. And once you start working with the data, you find things that you did not expect. So by implementing AI, we have an opportunity to fix those things. And you can write things to adjust for it.
Human bias is less than human bias.
Yes, you can make the algorithms less biased than the human bias, yes.
Maybe just a last question.
Last question.
Yeah, I was just curious what opportunities you see for startups in AI or elsewhere that really are outside the purview of regulatory and the FDA. I mean, what do you see as an opportunity for new application in AI that doesn't have to go through that rigorous clinical process?
Well, if you work with real data, it's regulated. So the actual data access is regulated for all personal information. So I don't know if there is a way So you will have still to follow the laws, HIPAA and other things. So there is no way around it. Unless you develop algorithm, like say for another country, which doesn't have those laws. But every time you deal with personal data, you have the regulation.
But consumer health monitoring devices are certainly Apple Watch, so forth. All Apple are monitoring healthcare monitoring, but they don't include that.
Yeah, most of the devices are regulated by FDA. If it's sold as a medical device, it will be regulated. Yeah, I think I don't know where there is no regulation in the healthcare system. It's a regulated industry. I think the regulation is often not as bad as people think. So there are ways to deal with it. So that's kind of my advice. Don't be turned off by the regulation itself.
Are these slides available somewhere?
So yes, we'll make the slides available. I'll post it on the.
How would I get them?
If you go.
On the meetup page, there's a discussion thread. So I asked the speaker to post a link to the discussion thread. And in general, for other talks, I asked the speakers to do that as well. So if you would look at past talks, I encourage that.
Okay. Thank you.